Precalc chapter 8 section 5, so binomial theorem. So let's first start by using this pattern, looking at this pattern of a binomial to some pattern. So x plus y to the nth. How does that pattern work? So we have x plus y to the 0. Anything to 0 power we should know is 1. X plus y to the first is just going to be x plus y. If we have x plus y squared, we should be able to FOIL that out, and we'll get x squared plus 2xy plus y squared. And so we start looking at patterns we see in here. And so we can look at x plus y cubed. If you do that, you get x cubed plus 3x squared y plus 3xy squared plus y cubed. And so let's see if we can find patterns from here. And you could have found this last one, cubic. We could have done x plus y squared, which is the answer from the previous one, and then distributed the x plus y into that. But if you look at this, you look at your exponents. We have x to the first, y to the first. Here we have x squared, then we have an x to the first, y to the first, and y squared. So all of the degrees of these terms are all going to be 2. Each term is degree 2 because you add the degrees of the variables within this one term. So here we have 3, 2 and 1, which is 3, 1 and 2, which is 3, and then 3. So notice how the degrees of each term add to be the degree of the polynomial or the binomial from the original problem. And so we can look at how the degrees change. So here's x to the first, y to the first. Here's x squared, x to the first, and this could be like x to the 0. The y, so there's no y's, then y to the first, then y squared. So then this one you have x cubed, x squared, x to the first, and then there's no x's or x to the 0, and then y's go reverse. And so you can see how they decrease for your first variable, for the first term binomial, and they increase for the second variable or the second term in your binomial. And then we look at our coefficients, so like the 1, 3, 3, 1. And then that comes from this Pascal's triangle as we go along it. So if you look at Pascal's triangle here, we have a row. First row is row 0, so 0 is 1. Row 1 is going to be 1 and 1. Row 2 is going to be 1, 2, 1. Row 3 is 1, 3, 3, 1. So how am I finding that? I'm looking at adding the two numbers to get the new middle one, the number between them. The 2 and the 1 is 3, and the outside are always 1s. And so we continue that pattern for row 4. It's going to be 1, and then 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1. And so you can create Pascal's triangle to help us find these numbers, which end up being the coefficients for our expansions in our binomial theorems, our binomial powers. And so then our next one is x plus y to the fourth. So let's find this one using our rule. So the fourth power, so it's the fourth row. So let's use the fourth row here. So these are going to be the coefficients for each term. So you're going to have a 1, and then it's going to be x to the biggest degree, 4, the degree of the binomial, and then y to the 0. And I can show you that so you see how it starts off at 0. Plus 4, it's our next term in the Pascal's triangle, and then x decreases by 1, and then y increases by 1, and then plus 6, x squared, y squared, plus 4, x, y cubed, plus 1, x to the 0, y to the 4th. And so hopefully you can see all the patterns within that one. And so the next one is x plus y to the 5th. And so you can try this one on your own if you want to pause this, and then you can check to see if you're on track here. Here's our Pascal's triangle. So you get 1 x to the 5th, y to the 0, plus 5 x to the 4th, y. So plus 10x to the 3rd, y to the 2nd, plus another 10x to the 2nd, y to the 3rd, plus 5x, y to the 4th, plus 1 x to the 0, y to the 5th. So hopefully you can find all the patterns within that. If you can't, here's where they're listed out. So if you're given x plus y to the nth, here's the things you should realize. That each expansion has n plus 1 term, so 1 more than the degree here. The powers have the symmetry, so the x is decreased by 1, the y is increased by 1. The degree of each term is n, and then coefficients increase and decrease in the same pattern, which is the Pascal's triangle. So binomial theorem, here's what you'll see on your formula sheet. You'll see the binomial to a power, and it expands it for you. And really the part you want to look at here is this will help you find any term. So you have the NCR, to talk about that here in a second, x to the n minus r, y to the r, where realize that n is the degree of the binomial, and then r, what in the world is r? R is always 1 less than the term you're at. So r is always equal to the term you're at minus 1. That's going to be the term number minus 1. Now that's how you can represent r. And so the relationship is, if you do n minus r plus r, it'll always equal n. So what is NCR? NCR is a notation we'll use the rest of this chapter. So you can look at it as NCR like this. It could also be written with the parentheses with n over r. It means the same thing. What does NCR mean? It really talks about the number of combinations that are possible. And so we'll look at that more when we start dealing with probability or counting. But for this case, to find that value is n factorial over n minus r factorial times r factorial. So a little bit of computation. You can also find it on the calculator by using your math key. Math, you should see the NCR function to find it as well. And so we can find like 9c2, and that's going to be 9 factorial if you want to write it out, and then 9 minus 2 factorial times 2 factorial. And we can simplify this a little bit. This is 9 factorial over 7 factorial times 2 factorial. This 7 factorial is going to reduce with the 7 factorial on the top, leaving us with 9 times 8 over 2. And the 2 here reduces with the 8, so I'm left with 4. And 9 times 4 is 36. So you can do that mentally. You can also punch in the calculator. So 11 over 4 is the same thing. It's 11c4. And so we could write that as 11 factorial over 7 factorial times 4 factorial, which is 11 times 10 times 9 times 8 all over 4 times 3 times 2. And I can reduce my stuff, so 4 times 2 is 8, which reduces 8. 3 and 9 reduce, so I have 110 times 3, so 330. So let's use that pattern to help us expand some of these binomials. So like x plus 2 to the 4th power. In previous, you'd have to like do x plus 2 times x plus 2 times x plus 2, and you'd have to FOIL these all together. And you'd have to like multiply, like FOIL these together and FOIL these together, and then get your answers and then do all the distributing, which would take a while. If you know your binomial distribution and the patterns, it should be pretty quick. So Pascal's triangle, we want row 4 for that. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And so you get to know Pascal's triangle pretty good as you use it. Just realize that this first one is row 0. So 1, 2, 3, 4. This is row 4 then. So those are our coefficients. So it's going to be 1x to the 4th, 2 to the 0. So I'm not going to include it. Plus 4x cubed times 2 to the 1st power, plus 6x squared, 2 squared, plus 4x to the 1st, 2 to the 3rd, plus 1x to the 0, 2 to the 4th. And so it's the same patterns we were just looking at in the first slide. So we can simplify this a little bit because we have our second term of binomial is a number. So we have this 2 here times the 4. So we get the 8x cubed plus 2 squared is 4 times 6, 24. And then 2 cubed is 8 times 4 is 32. And 2 to the 4th is the same thing as 4 times 4 or 16. So let's do it again. Let's do it for 5 minus 2y, a little more difficult, to the third power. So the third power would have been this row. So then we have 5 to the third power plus 3, and that comes from our Pascal's triangle, times 5 to the second power times negative 2y to the first power. Now notice how when I'm using this term, I'm including the sign with it, the negative. So you need to use the negative 2y for the term to include the negative. So when we have plus, we have another 3, 5 to the first power times negative 2y squared. Then we have plus the 1, 5 to 0, and negative 2y cubed. So 5 cubed is 125, plus 5 squared is 25, times 3 is 75. 75 times a negative 2 is a negative 150 y. So for our next term, we have to make sure that this 2, this square, goes to negative 2 and y. So negative 2 squared is 4. 4 times 5 is 20. 20 times what's positive, y squared. And then the next one, we have negative 2 to the third power, which is going to be negative 8y cubed. And so this would be the value, or the expansion. And if you want to rearrange it so it's in the standard form, you could do that. Typically when we write these, we go from the greatest degree to the smallest degree. Notice how our signs will flip: positive, negative, or negative, positive. And that's typical as well with these. So we're trying to find the seventh term here. The big thing is, do you know what r is? R here is always going to be one less than the term you're trying to find. So the seventh term, then r is going to be 6. So it's r plus 1 term is what you're trying to find. We're going to use this formula to help us find the specific term. So if we're trying to find the fifth term of this binomial power, so we need to know or express what n is and what r is. N is the degree or the power of your binomial, which is going to be 8. R is always one less than the term you're trying to find. So the fifth term, so r is going to be 4. And so now we can plug that into the formula here for any specific term. So it's going to be 8c4, and then it's going to be x. X right here is whatever the first term of your binomial is. So a to the 8 minus 4 power, and then times your y, which for our case is 2b, to the r value. So 8c4, again, you can find that's 8 factorial over, for this one's going to be 4 factorial times 4 factorial, which is, let's see, 8, 7, 6, 5 over 4, 3, 2. So again, 4 and 2 is 8. 3 goes into 6 2 times. So we have 35 times 2 or 70. So if I evaluate this, I get 70, a to the fourth, and then 2 to the fourth here is 16, and then b to the fourth. And so last thing I do is multiply 70 times 16. You get 1120, a to the fourth, b to the fourth. That would be the term, the fifth term, and the expansion of this binomial to the 8th power. If you wanted to write it out, you could, and then find what the fifth term would be, but that typically is a little bit longer than going through the process of just using this formula. So we'll call it good.